Alright, so in this video we're going to talk about the four basic function operations and how to calculate some things with functions using these function operations. So if we begin by having two functions, f of x and g of x, then these are the four basic function operations. We have function addition, function f plus function g of x, that's the sum of the two functions together. We have function subtraction, and that's when we subtract one function from another, f minus g of x, that's f of x minus g of x. We have function multiplication, that's when we take two functions f and g and multiply them together and we get f of x times g of x. And we have function division. Right? That's when we take two functions f of x and g of x and divide them, and the denominator in this case when we do function division cannot be 0. Alright. So those are the four basic function operations. In a general form, let's actually do them with some calculations here. Alright, so let's assume f of x is x squared plus x minus 6, and the function g of x is x minus 2. And the problem says let's find f plus g of x, f minus g of x, f times g of x, and f divided by g of x. Alright, so first off, let's find f plus g of x. Remember, that's a sum of f of x and g of x. So we take the function f of x, x squared plus x minus 6, and we add the function g of x to it, plus x minus 2. And from here, because it's function addition, we can combine like terms. And when we combine like terms, x squared, there are no other like terms, so we keep that. Then we have plus x and plus x, that's going to make a plus 2x. And then negative 6 minus 2, that's going to be minus 8 at the end. So the function f plus g of x is equal to x squared plus 2x minus 8. Now let's look at f minus g of x. Alright, that's function subtraction. So f minus g of x, that's the function f of x minus the function g of x. F of x is x squared plus x minus 6. G of x is x minus 2. And we're subtracting g of x from f of x. And the key here is we have to, since we're subtracting g of x from f of x, we should make this a positive and change the sign of everything in that parentheses there, because subtraction is really the same thing as adding the opposite. And then we get x squared plus x minus 6 plus a negative is minus x plus 2. And then we combine like terms. When we combine like terms, we get x squared, positive x and negative x. They now cancel themselves out. Negative 6 plus 2 is minus 4. So the function f minus g of x is x squared minus 4. Alright, so half the way there, we just have to do the multiplication and the division of these functions. If we do function multiplication here, f times g of x, it's going to be the function f of x times the function g of x. F of x is x squared plus x minus 6. G of x is x minus 2. Now, multiplication in the real numbers. Remember, we're dealing in the real numbers here. Multiplication is commutative here. So we can rewrite this as x minus 2 times x squared plus x minus 6. And then we can do the distribution here. We can do our multiplication of polynomials here. We can do x times x squared, x times x, then x times negative 6. And when we do that, we get x times x squared is x cubed, x times x is x squared, x times negative 6 is minus 6x. And then we do the same thing with the negative 2 here. Negative 2 to x squared, negative 2 to x, then negative 2 to negative 6. And we get negative 2 times x squared is negative 2x squared. Negative 2 times x is minus 2x, and negative 2 times negative 6 is a positive 12. And then combine like terms here. You get x cubed plus x squared minus 2x squared is going to be minus x squared. Minus 6x minus 12x, or minus 2x, that's going to be minus 8x plus 12. And that is our answer right there for f times g of x. Then the last one is the trickier one, f of x, f divided by g of x. Right, f divided by g of x. That's the function f of x divided by the function g of x. Right, and g of x cannot be 0 in this case, or because if it were 0, we would have a division by 0. So f of x is x squared plus x minus 6 divided by x minus 2. Think about this denominator here. What value makes the denominator 0? Well, if we solve x minus 2 equals 0, if we solve x minus 2 equals 0, we get x equals positive 2. That value of x is what x cannot be, or else we would have a division by 0. That's what we talk about when the denominator here can't be 0. And from here, we can simplify this using either factoring or long division or synthetic division. Whichever method works is fine. If you can't do it, then it's in simplest form. Right? But I know for a fact the numerator here can be factored as x plus 3 times x minus 2 divided by x minus 2. And what you notice is the numerator and denominator have the same factor of x minus 2, so they simplify out, and you're left with just x plus 3. So f divided by g of x is x plus 3. And that's the basics of function operations here. Alright, so second group of examples here are pretty much the same thing as the first examples, except now, instead of having an arbitrary variable, right, finding the function addition, subtraction, multiplication, or division, evaluated at a value of x, now our value of x is going to be defined. We're going to use the same process, and I'll show you a shortcut to doing these after we go through the whole mathematical process for this. So first off, let's look at these two functions here, x squared minus 7x and g of x is x plus 5. Let's first evaluate f plus g at 2, at the value of 2. So if we look at f plus g of x in general, right, that's going to be the function f of x, which is x squared minus 7x plus the function g of x, x plus 5. Combining like terms gives us x squared minus 6x plus 5. Now to find the function f plus g evaluated at 2, wherever there's an x, we substitute in a 2. So we get 2 squared minus 6 times 2 plus 5. 2 squared is 4. Negative 6 times 2 is negative 12 plus 5. 4 minus 12 is negative 8 plus 5 is negative 3. So the function f plus g evaluated at 2 is equivalent to negative 3. Now, alternatively, you could have evaluated the function f at an x value of 2, then evaluated the function g at 2, and added their results. So if we did that, and did f of 2, we would get 2 squared minus 7 times 2. 2 squared is 4. Negative 7 times 2 is negative 14. 4 minus 14 is negative 10. And then if we evaluated g at 2, we would get 2 plus 5, which is 7. And then when we take both of these values and add them, negative 10 plus 7 is going to be negative 3, which is exactly the answer that we got doing it the theoretical way. Both those ways are 100% correct. One's a little shorter, one's a shortcut, the other is the more advanced, more theoretical type of approach to it. But both are equally accepted. Let's move on to the second one there, f times g evaluated at negative 3. Alright, so if we do f times g of x, that's going to be x squared minus 7x times x plus 5, distributing x squared gives us x cubed plus 5x squared, and then distributing the negative 7x gives us minus 7x squared minus 35x, and then combining like terms gives us x cubed minus 2x squared minus 35x. And then evaluating f times g of x at negative 3, that's replacing wherever you see an x with negative 3, and we get negative 3 cubed minus 2 times negative 3 squared minus 35 times negative 3. Negative 3 cubed is negative 27. Negative 3 squared is positive 9. And negative 35 times negative 3 is going to be a positive 105. Negative 2 times 9 is negative 18. Negative 27 minus 18 is going to be negative 45. Plus 105 is going to be 60. So the function f times g evaluated at negative 3 is going to be 60. Alternatively, if you evaluated the function f at negative 3, you would get negative 3 squared minus, let me write this a little somewhere else so we can have some room here. Alright, if we evaluated f at negative 3, we would get negative 3 squared minus 7 times negative 3, which would be positive 9 plus 21, which is 30. And if we evaluated g at negative 3, we would get negative 3 plus 5, which is 2. And then if we took the results here, f of negative 3 and g of negative 3, which are 30 and 2, and multiplied them, 30 times 2, that would give you 60, which is exactly the result that we got by doing it the long drawn out, long way. Okay? So that's the basics of function operations. There is one more topic with function operations, and that's function composition, which is coming in another video. Okay, so those are the basics regarding function operations. The big thing to remember here is combine like terms. If you subtract one function from another, you have to make the subtraction a positive and change the signs of everything in that function. And division, the bottom can't be 0, so you have to state some sort of restriction on x or on your variable.